Whew, muy caliente. So there's a lot of talk about forest fire these days, especially in the wake of climate change and their relation to logging practices, which I don't think a lot of people understand. So let's break it down. Okay, so fire is a naturally occurring event in many forest ecosystems, and these fires are often classified as either low intensity fires or high intensity fires. Now, low intensity fires burn primarily through the understory or brush of a forest, which provides many benefits to the ecosystem as a whole, such as returning nutrients to the soil as ash or reducing competition or obstruction on the forest floor so that young saplings have an opportunity to get light and grow. Now, since healthy, mature forest ecosystems host a diversity of tree ages and species that are much more older, fire-resistant trees that can withstand these low-intensity fires, and many ecosystems have actually evolved in tandem with these fires. For example, Douglas fir hemlock forests in central Cascadia rely on these frequent low-intensity fires to clear the underbrush and allow opportunities for new Douglas fir trees to grow, and without that disturbance, those older Douglas firs would slowly die out and the forest would mature into a late successional stand dominated by western hemlock. Now, fire has also been used by indigenous people since time immemorial here in Cascadia in environments such as oak woodlands, which surround the Salish Sea, where frequent human-created low-intensity fires help clear grasses and underbrush to allow for Oregon white oak trees to thrive without being overtaken by the surrounding conifers. So these low-intensity fires are estimated to happen naturally throughout forest ecosystems in the West every 50 to 100, sometimes 250 or 500 years, depending on the specific ecosystem and its climate, which can all vary greatly. Then, on the other hand, you have high-intensity fires, which occur naturally as a result of compounding factors which makes forests extremely vulnerable, such as long-term drought or disease affecting a forest, and these fires look much different from low-intensity fires. You know, they're often known as stand-replacing fires because they tend to burn literally everything in the forest from old trees to young, replacing the entire stand because they burn with such high heat and intensity that nothing can escape them. Naturally, these types of fires are estimated to occur every 500 to 1,000 to 2,000 years, again, depending heavily on the region and location of the specific ecosystem, and in some areas they've never occurred, like directly on the wet west coast of Cascadia. So in forestry, a really common justification for current management practices is that the methods we're using to cut and replant trees replicates natural disturbances such as landslides or fires, which for the most part is totally correct. You know, often when these forests are cleared, at least here in Cascadia, they're replanted with successional species like Douglas fir or red cedar out on the coast, spruces or pines more interior, that all do well in open sunny environments and are usually the first to occupy areas of disturbance that occur naturally in these ecosystems. Yet our, quote, fire-replicated disturbance logging practices are troublesome because they often mimic high-intensity fires that removes everything from the ecosystem, not the low-intensity ones that actually help ecosystems thrive, which brings up issues relative to both volume and frequency. Now, there's some discrepancy in reporting here, mostly around the term old growth and how it's defined, but varying sources suggest that at this point, between 90 to 96% of the original forests across the United States have been logged or modified, and between about 75 to 90% of Canada's original forests, with much of what remains being up in the northern boreal forest. So, for the sake of this discussion, we'll average that down to, say, 85% of forests across the whole of North America have been cut down in a manner that replicates high-intensity fires. Speaking to volume, that is an absolutely ridiculously huge percentage of the forest lands across the continent that have all been lost, and the forests that we replace them with are often tightly packed, even-aged monoculture stands of trees, like this one here that is routinely sprayed with glyphosate to keep deciduous tree competition down. Now, these dense monocultures lack diversity and thus resilience, making them more at risk to natural disturbances like those high-intensity fires we're replicating, and when combined with climate change factors such as drought and disease spread, that means that those rare, high-intensity fires are happening much more frequently and on massive scales, which is a big factor in the increasingly dangerous fire season we're seeing every summer. Okay, now the second problem here is frequency. You see, these virgin forests can be thousands of years old, maturing in hundreds, if not thousands of years, yet we replace them with trees that we cut down on 70-year rotations, sometimes shorter, and many forests on the East Coast are now third or fourth generation crop forests. So, through our actions, we've created a situation where within the last 400 years, and especially the last 100 years, over 85% of the continent's original forest ecosystems have been destroyed to the equivalent of being burnt to the ground in a high-intensity fire, in some places 4 times over, which statistically only ever occurs naturally every 1,000 to 2,000 years, if at all, yet we're calling all of this totally natural and sustainable. You know, the horrible fires we see every summer on average burns less than 0.008% of all the forests on the continent. Can you imagine if we lived in a world where 85% of the continent burned to the ground in just a couple hundred years? I mean, if you ask me, that doesn't quite sound ecologically sustainable or responsible. It sounds more like the apocalypse. So instead of trying to replicate these high-intensity burns in our logging practices, we need to allow our forest ecosystems to mature in a much healthier manner over a much longer period of time, and we need to spend a lot of energy and resources properly thinning and restoring the ecological function of the billions of hectares of mismanaged second growth that we've created. By replicating low-intensity burns with closed canopy and selective harvest forest methods, we can create not only a more humble, sustainable industry and jobs, but we can restore old growth characteristics to our forests to improve the ecological health and function of the lands we live amongst for a better future for us and all life on this planet. Let's do better.